So minus minus on both sides will get cancelled. Okay. When you solve this, what you'll get 5k is equals to 32. K is equals to 32 by 5. Okay. So now we have got the k value. So if you substitute this k value in 8 or 9, you will get the lambda value. So after getting lambda and k value, if you substitute in any 5, 6, 7 equation, you will get the, what is there? Lambda and mu we got. So mu value you will get. Okay. So 8 or 9, you substitute the k value. We can substitute in 9, no? 9 or anything. Anywhere if you substitute, you will get one lambda value. So substitute k value. So in 9 we can substitute k in 9. What will get 2 into 2 lambda. 2 lambda minus 3k. What is k? K is 32 by 5 equals to 2. Okay. When you cross multiply 10 lambda minus 3 2s are 6. 3 3s are 9. 9 by whole thing we can take it as 5 equals to 2. That is 10 lambda minus 96 equals to 10. 10 lambda equals to 10 plus 96. That is 106. Lambda equals to how much will get 106 by 10. So it is 2 5s are 10, 2 3s are 6. So 53 by 5. This is the lambda value. So we have got lambda and k value. Now we have to find the mu value. So 5, 6, 7 equations are there. No? So in that any 3 equations, you substitute the lambda and k values. So substitute lambda and k in what is the 5th, 6th, 7th equation. So 5th equation, if you substitute in 5, you write in 5. In 5 means 53 by, what is 5? Lambda minus 6k minus mu k equals to minus 3. So lambda minus 6k. 6 into 32 by 5 minus mu into k. What is k? 32 by 5 equals to minus 3. Okay. This is the equation we have. Any cancellations are not there. So for all we have 3 is there. If you take out common and if you do the cross multiplication, you will get 53 minus 6 2s are 12, 1, 6 3s are 18, 19, 192 minus 32 mu is equals to 5 3s are minus 15. So we need mu value, no? Minus 32 mu is there equals to minus 15. So minus 92, if you'll take out 53 from this means 9 you will get here 18. 18, 8, 5 means 3. So 139. 139. So implies minus 32 mu is equals to minus 15 minus 139. If you add 15, 4, 1, 3, 2, 4, 5, 154. So what you'll get? Okay, here minus you will get, no? This is minus is there. So here you will get it as plus. Plus 139 is the minus sign. So from that we have to minus 15. So it is 4, 124. Okay. So here we'll get the mu value equals to minus 32 mu is equals to, this is 124 we get. So mu is equals to 124 by 32. Minus sign is there. 4, 8 4s are 32. 8 1s are 8. What for 8? Should get 31 by 8. With 4 we can do. 4 8 are 32. 4 3 are 12. 1. So it is equals to 31 by 80. So we got here all the values. First one is therefore mu is equals to 31 by 8. Lambda is equals to 53 by 5. And K is, what is K value? K is equals to 32 by 5. Okay. Now we got all the values whichever we have taken them as a here terms for combining the plane equations. Okay. Now when you substitute here lambda value in the third equation, starting we have third equation, no? And when you substitute the mu value, here we got lambda and also mu. If you substitute there, then you will get the two plane equations, whichever they will have the xyz quotient as the same. Okay. Then we can tell that these two, whatever the line equations are there, those two line equations, we can find the shortest distance. Here the main aim is to find the shortest distance and also equations. So here substitute lambda in 3. Okay. In 3 means it is 3x minus 9y plus 5z. What is lambda? Plus 53 by 5 into x plus y minus z equals to 3. When you cross multiply this one, 5 3s are 15x, 5 9s are 45y, plus 5 5s are 25z, plus 53x plus 53y minus 53z equals to 0. Okay. So 15x plus 53y is there. So how much will get? 68. So able to see this, no? 68x and minus and plus, if you do means it is 6 plus 8y minus 28z equals to 0. So when you take out here, okay, we can take 4 common here, no? 4 sevens are 28, 4 twos are 8, and here 4 ones are 4, 4 sevens are 28. Okay, just to form it in the simple way. Take out here 4 common from the equation. Okay, when you'll take out here 4 common. So here we'll get 4 if you take out common. 17x plus 2y minus 4 sevens are 28. That is 17x plus 2y minus 7z equals to 0. What is this equation? We have completed 7, 8, 9, no? 9th equation, this one. 7, 8 we have completed. Equation is also completed. So this is 10th one. Next, we have to substitute the mu value in 4th equation. Substitute mu equals to how much? 31 by 8 in 4th equation. So 4th equation is 6x plus 8y plus 3z minus 10. What is mu value? Mu value is minus here. So check this one. Okay. Here minus sign was there, no? Minus. So it is minus 31 by 8 into x plus 2y plus z minus 3 equals to 0. Okay. If you cross multiply this one, 6 8s are 48x, 8 8s are 64y, plus 8 3s are 24z, minus 80 minus 31x minus 62 minus 31z minus 3 3s are 9 93 equals to 0. Minus into minus, this will become plus. Okay. So now when you simplify this, you see the simplification of this one. You will get it as 17x minus 20 plus 2y 24. This is minus 7z. This you will get as plus 30 equals to 0. This is the 11th one. Okay. So you will get the equations which are having the quotients of x, y, z as the same. So starting what we have taken whenever a third and fourth equation we have got now, there we have taken one condition that the two, whatever the plane equations are there, those two plane equations are, we have taken them as parallel. So which plane equations are called as a parallel means whose x, y, z quotient are same, but the constant are different. Okay, here we are not having constant value, but we have here. But whatever the quotients of x, y, z are there, if they are same, then we call the two planes or two lines, whatever are there, in lines also. Okay. So two planes are parallel to each other. Okay. So we got here same quotients of x, y, z are same, but here the constant value will be different. So such type of planes are called as parallel planes here. Okay. So now we have to find, first thing is we have to show that they are parallel to each other. That we have done. Why we are showing these two lines are parallel to each other? Because we have taken, after taking the third and fourth equation, we have written one condition that the two planes are parallel. Then we have taken the quotients of x, y, z. They are those two quotients. We have equated them with the help of k. Okay, why we have taken k? So that is whatever the x quotients in equation, that is a third equation and fourth equation, whatever it is there, we have equated them with the help of one more term. The term is k here. Now to find the shortest distance when the two lines are parallel to each other, this condition, if you want to see the formula, you have in first unit. Okay. When two lines are that is two planes are parallel to each other, then how to find the distance between them? The formula is that is d2 minus d1. Here d1 and d2 are the constant terms in the equations. d2 minus d1 for both the parallel line planes, what will have x, y, z quotients will be same. So it is d2 minus d1 by under root of a square plus b square plus c square. That is the formula for finding the distance between the two parallel planes. Okay. So here therefore SD between 1 and, that is the shortest distance between 1 and 2 lines equals to distance between the lines here 10 and 11. Okay. Here shortest distance is equals to this one. It is the formula I am writing here. d2 minus d1 by under root of a square plus b square plus c square. So when you substitute the values, here d is 13 is there, but we don't have here d1 value. Okay, you can take it as 0. And under root of it is 17 whole square plus 2 whole square plus minus 7 whole square. Okay, so it is 13 divided by, so 17 square means it is 289 plus 4 plus 7 7 is 49. It is equals to 13 by this whole thing. After doing the simplification, you will get 3 into root of 38. Okay, you add them and see this one. Okay, where you can verify. So your shortest distance is equals to 13 by 3 into root of 38. Okay. So first part we have completed, finding the shortest distance. Now we have to find the two equations. Okay. So for the two equations, this is if 3 is perpendicular to 9. Whatever the ninth equation is there, that is 3 plus lambda. Sorry, perpendicular to 10th equation. So 3 we have now third equation with the help of the lambda. So whenever the two planes are perpendicular to each other, we know the formula is L into L1 plus M into M1 plus N into N1 equals to 0. Okay. So third plane you can see from that, if 3 and 10 are perpendicular, then third excoefficient is 3 plus lambda into this excoefficient is 17 into 17 plus 2 into minus 9 plus lambda plus 7 into 5 minus lambda. Okay. L into L1, M into M1, N into N1 equals to 0. So when you simplify this one, 17 3s are 51 plus 17 lambda minus 18 plus 2 lambda minus 7 5s are 35 minus into minus plus 7 lambda equals to 0. When you simplify this one and when we find the lambda value, you will get it as this is 26 lambda plus 2 equals to 0 minus 2. Okay. Minus 2 equals to 0, that is lambda equals 2 by 26. It is equals to 1 by 30. Okay. So we got here lambda value equals to 1 by 30. And similarly, line 4 and line, you can take either 11 or you can take any one. Okay. Are perpendicular, then similarly, if 4 and 11 are perpendicular, then, so what is the quotient of 4 means 6 plus mu, that is 17 into 6 plus mu plus 2 into 8 plus 2 mu minus 7 into 3 plus mu is equals to 0. So when you simplify this, we'll get here mu value is equals to minus 97 by 40. Okay. So do the simplification, that first you multiply, then you find the mu value. So here we got the mu value and also lambda value. So whenever you substitute this mu and lambda in third and fourth equations, we'll get the equations here. So therefore equation to the plane, therefore equation to the plane through 1 and perpendicular to 10. Okay, and perpendicular to 10 is, so whatever the line 1 is there, line 1 in the question it is given now 3x minus 9y plus 5z equals to 0 equals to x plus y minus 5z. Okay, there whatever the third equation is there, there we are substituting the lambda value. So here 3x minus 9y plus 5z. So what we got here, lambda equals to plus 1 by 13 into x plus y minus z equals to 0. So cross multiply, 33 is 39 minus here this is 9 times. 39s are how much? 39, 9, 27, 9 ones are 19, 170. Plus 13 5s are 65. Z plus x plus y minus z equals to 0. When you simplify this, you will get it as 10x minus 29y plus 6z equals to 0. 16z equals to 0. Okay. If you want, you can check that one. Add all the constant terms. Whatever the terms are there, you just simplify that. Here is only there 39 plus x means 40x you will get. And minus this means you will get is 116. 165 minus z means you will get 65. After that, you take out the common. 40 is there, no? 4 if you will take out common, then you will get this one. This is the line equation. 10x minus 29y plus 16z equals to 0. Okay, here similarly, or also we can write also equation to the plane through second plane line equation and perpendicular to 11. Okay, and perpendicular to 11 is 6x plus 8y plus 3z minus 10 minus what was mu value? Oh, minus 97 by 14. Minus 97 by 14 into x plus 2y minus z minus 3 equals to 0. 14. When you simplify this, you will get the answer. 14, you do the cross multiplication, then you do the simplification for this one. So you'll get this answer as 13 by 10x minus 13x. $13x plus 82y plus 55z minus you will get 151 equals to 0. Okay. So here the two plane equations are these two and the shortest distance is this one. 13 by 3 into root of 38. So like this we have to solve the problem. So if you feel that this is a very lengthy process, so I have told it's your wish. You can use this method or that method for solving the problem. So first method is converting whatever the unsymmetrical form of lines are there, converting them into symmetrical form, and then you can use the same procedure. Last week we have done for finding the shortest distance and for finding the equations. And second method is this one. You have to join those two line equations with the help of lambda and mu. Then you have to equate those two equations with the help of the k term. Then you have to make the 5, 6, and 7 equations. By solving 5, 6, 7 equations, we'll get lambda, k, and mu values. When you substitute that mu and k lambdas, k values in the third and fourth equations, you will find the two lines, whatever the third and fourth equations are there, they are parallel to each other. So when they are parallel, we need to find the shortest distance. When the two planes are parallel to each other, whatever the distance between the two plane equations, when they are parallel, the distance is equal to the shortest distance. So when you find the distance, when you simplify that, we'll get the whatever the answer is there, this is the shortest distance. For finding the equations, we have to substitute the whatever the values are there. That is, third equation will be perpendicular to the 10th equation. When the two planes are perpendicular to each other, we have the condition L into L1 plus M into M1 plus N into N1 equals to 0. With the help of that, you will get lambda and mu values. When you substitute that lambda and mu values in third and fourth equations, we will get the equations of the plane. Okay, this is the procedure. If you simplify this one, somewhat it is easy only, but the procedure will be somewhat lengthy one. In first method also, for converting into unsymmetrical into symmetrical form, that will be half part. That is, you have to take z equals to 0, then we have to find x, y, z values. After that, you have to find the direction ratios, that is LMN values. For that, we have to equate those, whatever the unsymmetrical form are there, no? Those we have to take as a perpendicular equations. Then we have to find by the cross multiplication method, we have to find ABC values or LMN values. When you substitute in the formula, that is x minus x1 by L equals to y minus y1 by M equals to z minus z1 by n where. Then we'll get the that is line equation in symmetrical form. So after getting the two, that is first line equation with the help of the planes, the same procedure you have to do. And for second line also the same procedure. After getting the line equation symmetrical form, with the help of the first method we have seen last week, that is also lengthy one. Here directly you can do, or you can do with the help of the first method. Okay. So this is the 10 marks question in unit 5. In this, only one more last topic is there, which you will get for the 5 marks question, that is finding the nature of intersection of the planes. This concept. So this is the very regularly asked questions. In page number 138, you have intersection of 3 planes. 3 planes will be given. So you have to find the nature of the intersection of those planes. In page number 140, here above the example problem 5.4.1, here 3 conditions are there. These 3 conditions are important. So whenever one lambda value you will get as 0, lambda value is equals to 0, and lambda 1, lambda 2, lambda 3 values also if we get as 0, then the whatever the 3 planes are there, they will intersect in a line. This is one condition. Second one is when lambda equals to 0 and lambda 1, lambda 2, lambda 3 values are all not equals to 0, then the 3 planes will form a prism. Okay, that is the second condition. And third condition, if lambda itself is not equals to 0, then we'll say that they intersect at a unique point. So this is the 3 conditions. If you know these 3 conditions, then in the given problem, you can find whether they are intersecting at a point, or whether they are forming a prism, or they are intersecting at a unique line. Okay. So you can solve the problem with the help of this one. So we'll see one problem regarding of this one. So in page number 140, whatever the 1, 2, 3 are there, no, they are given in the sentence form. If you'll see that to know how to solve the problem, just you write after first condition, this condition is applicable when lambda equals to 0, and also lambda 1, lambda 2, lambda 3 values also equals to 0. Okay. Second condition is that lambda equals to 0, but lambda 1, lambda 2, lambda 3 values are not equals to 0. Okay, in working, this is the working rule for solving the problem. Third one is lambda itself is not equals to 0. So whenever lambda is not equals to 0, directly we can write that it is intersecting at a point. Okay. But first two conditions are important, whether they are intersecting a line or whether they are forming a prism. Nature of intersection of 3 planes. So here lambda 1, lambda 1, lambda 2, lambda 3 are, whenever 3 planes are given, already we have studied about the Kramer's method we have now in matrices. Through that method, we have to solve the problems. Okay, nature of intersection of 3 planes. Nature of intersection of 3 planes. Okay. So first one is, that is lambda is equals to 0, lambda 1, lambda 2, lambda 3. If also these 3 also equals to 0, then 3 planes intersect in a line. Okay, this is the first condition. Second one, if lambda equals to 0 and lambda 1, lambda 2, lambda 2, lambda 3, if these 3 values, whatever you are getting, if they are not equals to 0, then 3 planes form a prism. And third one is, if lambda itself is not equals to 0, then three planes intersect at a unique point. May intersect in a unique point. Okay, these three conditions are important. So first one, we will see the problem. So a question will be from the MEQ, I am telling, find the nature of intersection of the planes. Find the nature of intersection of planes. So here three planes are 3x minus y plus z minus 5 equals to 0. 2x plus 4y plus z plus 10 equals to 0. 6x minus 2y plus 2z plus 9 equals to 0. Okay. So here lambda means members. Duration of class. So here lambda is equals to, so write xyz quotients, that's all. That is 3, minus 1, 1, 2, 4, 1. Next 6, minus 2, 2 here. So we have to find the determinant of this one. So when you find the determinant of this one, this value will get it directly. I'm writing this. That is 3 into 8 plus 2 minus of minus means plus 1. You will get 4 minus 6 plus 1 into minus 4 minus 24. Okay. When you do simplification, this will be equal to 0. So that means when lambda equals to 0 means this may be first or second condition. So when you find the lambda 1. So finding the lambda 1 means here whatever the constant values are there, minus 10, minus 5, 10, 9. Lambda 1 means here whatever the first column will be there, that column you have to take the constant terms. So if you know about the Kramer's method, you can find that one. Okay, minus 5, 10, 9 here. Here this will be same, minus 1, 4, minus 2, 1, 1, 2. This is lambda 1. So this whatever resultant will be there, this will be not equals to 0. So I am not doing the simplification. Okay, you solve this. Lambda 2 is equals to 3, 2, 6. Whatever the constant values are there, you have to write it as first column in lambda 1, in lambda 2 in second column. 1, 1, 2. Okay. So this also you will get it as not equals to 0. And even lambda 3 is 3, 2, 6, minus 1, 4, minus 2. And here minus 5, 10, 9. Okay. This also, if you do the simplification, you will get it as not equals to 0. Okay. So this is the second condition. Lambda value we have got 0, and lambda 1, lambda 2, lambda 3 values you are getting as not equals to 0. So whatever these planes are there, they form a prism here. Okay. At last you write that they form a prism. So this whatever the answers are there, try to solve them. That is fine. Just the determinant for the one. So by this we are completing the block 2. So if possible, we'll go to the block 3 regarding of the equation of the sphere. Okay, tomorrow we'll see. Tomorrow is the last class we have.